Hi, good evening, everyone.
Good evening, ma'am.
Good evening, everyone.
Good evening, ma'am.
Can you all hear me?
Yes, ma'am. Good evening.
Okay, Neha, the action come on the screens, and Harshit is left. Yesterday, last we did conductors, insulators, and semiconductors.
Yes, ma'am.
Okay, so Neha, state a few examples of conductors. Neha, state a few examples of conductors.
Ma'am, can you repeat?
Examples of conductors.
Yes, ma'am. Examples of conductors include metals like silver, copper, and gold. These are the three main conductors, like really good conductors. Ma'am, can you hear me? Ma'am? Ma'am?
Yeah, I'm sorry, children, there was something urgent.
Yes, ma'am. Examples of conductors include metals like silver, copper, gold.
Are the action examples of insulators or non-conductors?
Ma'am, rubber.
Hmm.
Ma'am, rubber.
More. Speak loudly. Speak loudly. Your voice is too low.
Rubber.
After rubber. Dear, why you both of you are turning off your cameras? Come on the screen. Be here. Be on the screens. And Trilokya, examples of semiconductors.
Ma'am, silicon and germanium.
Okay,
And
fine. So our next topic is next we need to discuss about solubility and insolubility of substances. We're just sharing screen.
ma'am, rubber, wood, and gold, ma'am.
So first is, what are soluble substances? The substances which completely dissolve in water are called soluble substances. I hope we already know about it, right? So examples of soluble substances are salt, sugar, like coffee powder. We just need to, mix them a bit with the help of a stirrer, and they will dissolve completely, like it forms a homogeneous mixture. After mixing it well into the water, we cannot see the particles of salt and crystals of sugar separately suspended, like in the case of chalk powder or sand. If we mix sand or soil or chalk powder into water and leave them undisturbed for a while, for like 5 to 10 seconds only, we'll see all the particles of sand, chalk powder, and soil will appear to be suspended, and they will rest at the bottom of the container, right? So such type of substances are called insoluble substances. So very clear, soluble substances completely dissolve in the water. Insoluble substances do not dissolve and they remain separate. Okay, so please note down the differences along with example. And after this, you have to state more examples of soluble and insoluble substances.
Good evening, ma'am.
Good evening, Harshit. Why so late?
Ma'am, network issue.
So this much late? You could have messaged me in the group, the network issue. Noted, everyone? Harshit, we have just started the difference of soluble and insoluble substances.
No, ma'am, 1 minute.
Be quick, please. Think for more examples.
Ma'am, in insoluble substances, even oil is there. Oil.
Speak loudly, Neha.
Ma'am, even oil is an example of insoluble substances.
Yeah, insoluble. Rest, any of the flour, like we make chapati of wheat, so wheat flour, corn flour, etc., they will all not mix.
Ma'am,
Hmm?
ma'am, in soluble substances, sanitizer with soluble, ma'am.
Pardon, please, the action.
Ma'am, sanitizer will solute in it, ma'am, in the water.
Sanitizer.
Yes, ma'am.
You can try it if you want to see.
Ma'am, to the in test tubes, ma'am, she's shown that.
Okay, you mean that will not be soluble in water.
Yes, ma'am.
Okay. Noted the difference?
No, ma'am, I'm writing the examples.
Be quick, children. You take so much of time in noting down. Noted.
Yes, ma'am. No, ma'am.
I hope it is done.
Yes, ma'am. Ma'am, examples I'm writing.
Okay.
Yes, ma'am.
Done. Should I stop sharing?
Yes, ma'am.
Okay. Next is volatile and non-volatile substances. So how can we define volatility? Volatility is, you can say, the tendency of a substance to vaporize, okay, to convert into the vapor form. So volatile substances are those which go into the vapor phase. On heating also it is possible, or without heating they can vaporize. Whereas non-volatile substances, they do not vaporize rapidly, okay. So they will mostly be as solids in the room temperature only. Example, sodium chloride, silver nitrate, they all are non-volatile. As shown in the diagram here.
Ma'am, so volatile substances have like boil quickly.
Sorry?
So not volatile substances boil quickly and vaporize quickly.
You can say just on a bit of raise in temperature, they get converted. So yes, they have a very low boiling point. Means with just a gentle rise in temperature, they convert into vapor form. That's the nature of volatile substances. Okay, now see the two different liquids, and means in here it is shown that blue color liquid is in the container and blue color atom. Let's assume that these are the solid substances. Okay, whereas this cream colored substance, brownish color substance liquid, as well as the solid molecules, you can assume it, right? So blue color is also have also started rising, means converting into vapor phase rapidly, whereas this is not the case with the brown ones. Okay, so this is the nature of volatile substances, that they readily vaporizes with heating or without heating. Please note down, with heating, yeah, upon heating, or without heating. Examples of volatile substances. Can you state examples of volatile substances?
Ma'am, camphor.
Camphor.
Ma'am, petrol.
Okay. Or you can say that nail remover, that is the chemical name of nail remover is acetone. One more substance is chloroform. They quickly evaporate. And on other hand, write down the definition for non-volatile also. The substances.
Ma'am, what is second one example?
Acetone, ACETONE. The substances which do not vaporize rapidly. Those are non-volatile substances. Examples of non-volatile are silver nitrate, you can say any salt, any sugar, they are non-volatile. If we leave them open at the room temperature, uncovered, they will not vaporize. Okay. These I'm writing the chemical names, like sodium chloride is the chemical name of salt that we use in cooking. Okay. And silver nitrate is not a food item, but it is also one of the substance.
Over, ma'am. Done, ma'am. Done, ma'am. Done, ma'am.
Next, after volatile and non-volatile substances, we have miscible and immiscible liquids. Can anyone tell what are miscible and immiscible liquids?
Ma'am, can I? Ma'am, miscible liquids are liquids which can dissolve in water, and
Okay.
immiscible liquids are liquids that do not dissolve in water.
In water only. So miscibility means dissolving of a substance or mixing of substance in water only.
Ma'am, in any liquid.
In any liquid, yeah. Because solubility mainly refers to the mixing in the water, but miscibility means if it is the ability of any liquid to completely dissolve in another liquid solution. Okay, it is just any liquid solution. So the substances which we are trying to check is soluble, is miscible or not, that can be solid as well as liquid. Whereas the one in which we are checking the miscibility should be always liquid. And two immiscible liquids then means very true, means very clear that it is the non-mixing of substances which remain separate. Okay. Dear, just one more thing I would like to share with you. Add few points in volatile and non-volatile substances. This volatile substances readily transfer to the gaseous phase. This already we have written. This is just another language. Next is, please add a point that volatile substances have a high vapor pressure. You need to add these points. Volatile substances have high vapor pressure, whereas non-volatile have low vapor pressure. So because of that high pressure, the point of boiling point also you must have mentioned that volatiles have low boiling point and non-volatile have high boiling points. Volatile substances have weaker intermolecular attraction and non-volatile have strong intermolecular force of attraction. Because of weaker intermolecular attraction only, the the molecules are trying to get separate and they are converted into vapor phase. Like in grade 5th, you must have learned that gases, the molecules of gases have more spaces between them. They have a weaker force of attraction and more space. That's why.
Ma'am, we have to write this only 4.
The first you have already written in the form of definition earlier. These 3 points you can add.
Okay, ma'am. Done, ma'am.
Okay.
No, I'm not done. Last 2 I'm done.
Then, ma'am. Okay. Next is miscibility. This is a very basic definition which is shown here. So miscible substances fully mix in another liquid in all proportions, and immiscible substances never fully mix in all proportion. To some extent, they seem that they have mixed, but not completely. Like alcohol and water, you can write milk and water. Okay. Whereas immiscible liquids examples are oil and water. Okay. Oil and water are immiscible in each other. Now I'm sharing next screen so you can note from there. Just a second. Is it visible?
Yes, yes, ma'am.
Hmm. So you can make that table form only. To note down the miscibility and immiscibility.
Ma'am, we need to write the definition also.
Sorry?
We need to write the definition also, ma'am.
Yes, because miscibility is a concept. Like miscibility refers to ability of liquid to completely dissolve in another liquid solution. And a distinct layer between two liquids will not form. Means you will feel like this is a single solution, but it is actually a mixture of two. So this is the nature of miscible substances. Okay. See, miscibility we are checking in liquid, but the substance for which we are checking may be a liquid, may be a solid. Getting it? For like salt and sugar, they are miscible completely. Okay, but we check their solubility either in either in milk or in water, or let's say vinegar, any like that. Whereas if you will mix two miscible liquids, very good example is oil and water, you will see a separate layer between them, whereas
Yes, ma'am.
water will always rest downside and oil will be floating on water. It is because the density of oil is lesser than water. So anything which is light by nature or lighter by weight will always float.
Okay, ma'am.
Noted.
Yes, ma'am. No, ma'am. Last one.
Hmm. I hope it is done.
Yes, ma'am.
No, ma'am, 1 minute. Ma'am, done.
Okay. Next difference is very interesting. I find it very interesting actually. This is combustibility, means the substances that can be combustible or not. Anyone out of you knows what is combustion? Whatever you know, you can share. What do you mean by combustion? 6th class, come on. Anything, anyone? See, let me tell you. Combustion basically means burning of a substance.
Burning process, ma'am.
Burning process, yeah. So burning of any substance. And if you do not know, let me tell you that burning of any substance requires the presence of air, right? See, actually, practically, ideally, we cannot create vacuum. Vacuum means absence of air, no air at all. And this is not possible to create this situation, right? So air is present everywhere. Those substances which can be burnt, and if they find a good amount of oxygen or good amount of air in the surrounding, they will keep burning until they exist, right? And until it lasts. Whereas the substances which not at any condition can burn, can catch fire, are non-combustible substances at any cost, right? Okay, you first write the difference of these two, then I'll tell you more. Just a second. Combustibility is a measure of how easily a substance will set on fire through fire or combustion. So a substance that can be burned to provide heat or power are called combustible substances. Example: wood, coal, kerosene, petrol, etc. And let me tell you, more examples are paper and cloth. They are also combustible. But if you see now, if you suppose bring the flame near to these substances, will wood catch fire very easily?
Yes, ma'am.
Yes. Okay. What about kerosene? What about petrol?
Ma'am, these catch fire.
They catch fire so quickly. Means wood still takes time to catch fire, to set on fire, but kerosene and petrol do not. Okay. Paper catches fire rapidly, but cloth do not. Cloth takes time to catch. Okay. So there is a difference between the two. Okay, I will let you know what. Next is non-combustible substance. A non-combustible substance material is a substance that will not ignite, that will not burn, and that will not support combustion. For example, water. Can water ever catch fire? No. Can iron catch fire? No. Steel will not, stone will not. At any cost, they will not catch fire. Right? Now, apart from combustible, there are two more words that you must have noticed, either in the traveling in the trains or flights or any public places: inflammable and flammable. Have you noticed?
Yes, ma'am.
So what is the difference? See, combustion means the substance which can burn at any temperature, at low temperature, at high temperature. If so quick, so takes long time, doesn't matter. If they can set on fire, they will be called combustible. But few substances like petrol, gasoline, CNG, okay, these substances, like just a small raise in temperature is required to them for them to catch fire. So such substances are called inflammable substances. So it is just about their ignition temperature, at which they can ignite easily, right? So okay, as the time is almost over, do one thing, that you have to write the difference of combustible and non-combustible substances. Get the information inflammable substances. Okay, is it okay? Is it okay, everyone?
What, ma'am?
You have to write about combustible and non-combustible substances. This is your homework. And find out the difference between flammable and inflammable substances. Okay?
Okay, ma'am.
Just give me a minute. Okay, children, we'll meet in the next. Bye.
Thank you, ma'am. Have a nice day.
Bye, ma'am. Bye, ma'am.